Now it is time to dig deeper into Hive construct. The first thing that I want to talk about is the data types. As you can see, there are various data types available. In the numeric data type, we have integers like tiny integer, small integer, int, big int. We also have float and double, and the decimal and numeric. In the date and time type, we have timestamp, date, and interval as the three data types. In string, again, we have three data types. String varchar, which can have a value from 1 to 65535, or char, which can have a value from 1 to 255. There are also some complex data types that are supported in Hive. The first one is arrays. This is how you define an array. So let's say you have a column which has to be an array. You define it as array and followed by the data type of the array. This data type can be the primitive data types that we have just talked about in the previous slide. Similar is the case with maps. You define a column data type to be map by using the map keyword and then mention the column name and followed by the data type. Struct is similar to JSON, wherein you mention the column name followed by the data type of that particular column. So there can be multiple column names defined in a struct data type. So these are complex data types that are available in Hive. Now comes the databases and tables. So what is a database? Database is a house which stores all the Hive objects. When you create database or tables or any objects as such, the information of these databases and tables will be stored in AWS Glue catalog that we have selected while creating the EMR cluster. We could have chosen some external database also like RDS MySQL or Aurora MySQL, but in this case we have selected AWS Glue to store the metadata. So whenever you create a database, that database can be seen in the Glue catalog. The next one is the tables. You use the create table statement to create a table. And these are the three different types of tables. The first one is a managed table, wherein the data lifecycle is managed by Hive. What does it mean is that when you create a managed table in Hive, Hive will manage the data, which means that Hive moves the data into its warehouse directory. We have not seen the warehouse directory yet. In the Hive demo, I'll show you the directory where Hive stores all the objects data. So the way you load a managed table, that you have the file, and from the file you load data to managed table, and Hive itself will put that data in the distributed storage in a directory that is mentioned by the warehouse directory. Now whenever you delete or drop a managed table, the data along with it will be deleted. Now let's say you do not want Hive to manage the table or own the table. That's where you create external table wherein Hive does not own the data. So in case of external table, what you do is you have the same file available in, let's say, in some other distributed storage like HDFS or S3. You create an external table and just point that external table to the location where the file is residing. So in this case, as I have already mentioned, Hive does not own the data. If you delete an external table, only the metadata of the table would be deleted, but the file would still be there in the location that it was earlier. Now the question is, when do you use managed table as opposed to external table? To be honest, managed table and external table are more or less similar, but let's say if you are doing all your processing with Hive, then you can use managed tables. But if you wish to use Hive and other tools on the same dataset, then you can use external tables. Finally, we have something called temporary tables, and temporary tables are visible only to the current session. When the session is over, the temporary table is deleted. Now, before going further, I want to talk about the file and storage format that Hive supports. When you create a Hive table using the create table statement, there are two very specific keywords that are used in the create table statement, which is highlighted here. The first one is stored as, followed by the name of the file format, and then row format followed by the name of the row format. We'll go these two one by one. The first one is the supported file formats, and these are the file formats that are supported: text file, sequence file, Parquet, Avro, ORC, RC file, and there are some custom file formats also using input format and output format. And now let's talk about the store as file format. So when you mention sequence file, the data would be stored as compressed sequence file. In case of text file, it is stored as plain text file. RC file would store the record as record columnar file format. In ORC, it will be in ORC format, and this is the only format that supports ACID transactions in Hive. We'll talk about ACID transactions later on. The most commonly used file format is Parquet, wherein the data is stored as Parquet columnar data format. Then we have Avro. We can store records as Avro file format, which are row-oriented file format. Finally, we have JSON file also, wherein the data is stored as JSON files. Then in addition to all these, we have input format and output format, wherein you can actually create your own custom storage format. And in input format, you have to mention the class name of the input format, and in output format, you'll have to mention the class name of the output format. Now these two are custom file format. So let's talk about the record or row format. You already know what is encoding and what is file format. In case of file format, the record is encoded in a specific format and stored in the file. The same is the case with record or row format also. So in this case, individual row is encoded in a specific format before storing it in the file. So what happens is that let's say you have an input file with records. Hive will read those records one by one from file, and you want to load these records to a Hive table. After reading the records from the file, these records would be converted to a Java object. Meaning, let's say if there are 10 records, then Hive will convert each of them to a Java object, and then we'll see 10 Java objects. So after that, as it is a Java object, we need to serialize based on the row format that we mentioned. So this is where the SerDe comes into picture. This serialization is done for each and every record objects that are there in the file, and then the record is written to a Hive table. Now if you think of the opposite, you read from Hive table. After reading, the record comes out as a serialized record. Again, SerDe comes into picture, wherein in this case, it will be deserialized before showing it to the end user. There are two types of serializer and deserializer on SerDes. The first one is native SerDe. So if you mention stored as while creating the table, it does not need to mention the row format explicitly. It will be handled by the file format itself. The SerDe library that Hive has is present in org.apache.hadoop.hive.serde2 library. So in case of JSON, you mention the row format SerDe to be org apache hive hcatalog data.json SerDe, and you have to store the file as text file. In case of CSV or TSV, comma separated values or tab separated values, the row format SerDe has to be org apache hadoop hive SerDe open CSV SerDe, and it has to be stored as text file. There can be custom serializer and deserializer also if you want to create and use them to implement the record or row format in Hive. Most of the cases you'll be using the file format, which is mentioned after stored as, to have native SerDe method available. So you do not need to mention separate SerDe for your rows and records. The reason is that if you store your Hive table with binary storage formats like Parquet, RC file, ORC, Avro, sequence file, etc., you do not need to mention the row format, because the row format is controlled by the file format itself. So you do not need a separate row format for your tables. Now let's say if you have to, I have given an example using Avro. So this is how you will implement a custom SerDe. We have this create table statement, and the name of the table is d_underscore test. In the row format SerDe, you mention the Avro SerDe, and in stored as, you mention input format and output format. So this is a typical way of representing or implementing custom SerDe for your Hive table. Let's talk about the create table statement in a little bit more detail. So there are three options. You can use create table, create external table, or create temporary table to create the table that you need. You already know the difference between these three. By the way, when you use only create table statement, it creates a managed table. And when you use create external table, it creates an external table. Similarly, create temporary table would create a temporary table. Then you mention the stored as, which is the file format that you want to store your records in. You do not need to mention row format SerDe unless you are using a custom SerDe. Then you can also mention a location in case of external tables. So there are some other keywords like table properties. We'll see those things later on. You can also mention primary key, unique key, etc. Let's take a look at the Hive write path vis-a-vis the Hive services. So you have already seen the Hive services. There are various services available. You have the Hive driver, then you have the Hive CLI, Hive server 2 web interface, and then you have Metastore server, file system server, and the execution engine. So let's see how does it work. So whenever you create a table, it will go ahead and tell the Metastore service that I'm creating a table with this particular structure, which is the schema of the table. And Metastore service will call the external Metastore database like RDS MySQL or Aurora MySQL or AWS Glue data catalog and store that structure in that Metastore database. It is as simple as that. Now you are just creating the table, you are not loading any data. Now let's say you are inserting data into the table. So what will happen is that again it will call Metastore service to check the name validity of the table name. And that's all. It will not check the individual columns because Hive does not enforce schema on write paradigm, it uses schema on read paradigm. After this is done, the Hive driver will talk to the file system service, and file system service will write this data into HDFS or any other distributed storage. Let's see the read path again vis-a-vis the Hive services. In the perspective of Hive services, the read path is pretty similar to insert data. So let's say you are trying to read data. It will go ahead and ask the Metastore service to validate the structure of the table and the columns that you have mentioned in the HiveQL statement. So now Hive knows that which columns of which table would be read. So it will go ahead and ask the file system service to read data from the distributed storage like HDFS. So while reading the data, if all the columns conform to the schema of the table, then the data would be shown. If some columns do not conform to the schema, the value null would be shown there. Let us go ahead and have some Hive hands-on exercises.